Today in this lesson we're going to be looking at finding a linear equation. So our learning intention is to learn the skill in calculating the equation for a relationship that has a direct variation. And what we mean by direct variation is as one variable increases, such as x, or decreases, another variable will increase or decrease at a steady rate. Okay. So some of our success criteria, we need to know that any linear relationship or direct variation can be expressed in an equation. And the equation could be y equals mx plus c. Now, some of you may have learnt this as y equals mx plus b. The plus c or the plus b really doesn't matter. It's just plus a constant. And the constant is going to be the y-intercept. And the m is going to be the gradient. Alternatively, we can rearrange this and write in the general form of ax plus by plus c equals 0. Okay. We can recognize that the equation of a line represents the relationship between the x-coordinate and the y-coordinate of any point on the line. Understand the dependent and independent variables and which is which. Can correctly provide the equation of a linear relationship by using the gradient intercept formula, y equals mx plus c, the point gradient formula, y equals minus y1, y minus y minus y1 equals m x minus x1, and using the 2 points, having 2 points and using the formula. Okay. So, biggest note is that any line can be written in the form of y equals mx plus c, where m is the gradient, and to calculate the gradient we should know that it's going to be the difference in the rise divided by the difference in the run, or rise over run. And there's the traditional formula, m equals y1 minus y2 divided by x1 minus x2. Or alternatively, you can use m, the gradient is tan theta, because if we have and that's tan based on the x-axis. So there's my x-axis. Here is a line. Here is theta. And it's going to be opposite over adjacent, which is tan theta. Yeah, so that's my gradient. And then obviously c is the y-intercept. So there are many ways to come up with the equation of these relationships. It just depends on what information we are given. So for example, we're going to use the gradient intercept formula. So here we're going to be given the gradient and we're going to be given the intercept. Okay, so knowing this, we can basically just plug it into this formula. So what is the equation of the line if the gradient is 2 and the y-intercept is 3? So the formula is y equals mx plus c. The gradient is 2, so where I see m, I replace that with 2. And the y-intercept is 3, positive 3, so wherever I see c, I put 3. So the equation is y equals 2x plus 3. If I do question 2, what is the equation of the line if the gradient is negative a half and the y-intercept is negative 4, so y equals mx plus c, simply plot it in. M is negative a half, keep the x, and the y-intercept is negative 4, so I just write in negative 4. Okay, b is the gradient of negative 5, y-intercept negative 6, so y equals mx plus c, m is negative 5, and the y-intercept is positive 6. Okay, and the last one is gradient is 3, and it passes the point of 0, negative 4. Well, some people might go, well, I've got a gradient, but I don't have the y-intercept. So I want to think about here is my Cartesian plane. 0, -4 is somewhere down here, and that's my y-intercept. Okay, so all I'm going to do, y equals mx plus c, m is 3, and c, well, the y-intercept's down here at -4. So that's the solution. If I want... Now, we're going to use the point gradient formula. It means that you're going to be given a point, and you probably already been given the gradient. You know what the gradient is. Okay, so we're going to find the equation of a line if it has a gradient of 2, positive 2, and it passes the point of -2 and 3. So the formula was a random variable of y minus the known variable of y equals the known gradient multiplied by the random variable of x minus the known variable of x. And where that comes from is that if we have the gradient of m equals y1 minus y2 equals x1 minus x2, let's just call this 1 for the time being. This is a random variable of y. Yep. I can rearrange this equation by multiplying both sides by x minus x1, which gives you m x minus x1 equals y minus y1, which is exactly that. Okay, and that's how it comes from. That's where it comes from. Okay, so we know what the gradient is. The gradient is 2. We'll just plug that in. I don't know this x, and I don't know this y, but I do know my x1 and y1. So my x1 is -2, so minus -2. Notice that I have a minus and then I wrote the negative as well, because that will turn it into a positive. And minus positive 3, because that's your x1 and that's your y1. All right, now it just becomes an algebraic equation that we can solve out. So we've got 2x plus 2y minus 3. Expand this, that's 2x plus 4. Going to bring that 3 across, plus 3. So y equals 2x, collect like terms, plus 7. Okay. Here we go, example 2. We've got a passing the point 3, 0, and it has a gradient of -2. So once again, we write the formula, y equals minus y1 equals m x minus x1. Okay, the gradient is -2. Replace that there. I don't have my arbitrary x or y, but my x is 3, so I'm going to minus 3, and I'm going to minus 0. Okay, so that just becomes y. I'm going to expand this out, minus 2x, and negative times a negative is a positive, so plus 6. And because we like things positive, we just go 6 minus 2x. It's the same thing. Yeah, just a little bit neater to present. Okay. Here I have example 3. We've got a gradient of 78 degrees and 41 minutes, and it passes through the point -1, -2. So we need to recall that the gradient m is also tan theta because of that rise over run thing. So if I plug in to my calculator tan 78 degrees and 41 minutes, alright, tan 78 degrees and 41 minutes, I will get the solution of 4.99. I'm just going, and for this point, I really should keep this whole thing, but as an example, I'm going to round it up. Okay, so 5, the gradient of 5. This is like nearest whole number. Okay. just for ease, okay? So now I have a gradient, and I now have a point. Using the formula, y minus y1 equals mx minus x1, gradient of 5. Don't know that x, but I do know that my first x is -1. Don't know this y, but my y1 is -2. So this becomes y plus 2 equals 5, x plus 1. And let's just solve. So I've got, expand the bracket, 5x plus 5 minus 2y. Y equals 5x plus 3. And that's the solution. Okay. Sometimes you're given 2 points. If you're given 2 points, you need to find the gradient first, and you can do that with this formula, m equals y1 minus y2 over x1 minus x2. And then once you've found that, then you can choose one of the points and plug it into the point gradient formula that we did here. Yeah, so it's a two-step problem. Okay, we'll do the first question. First, the equation of the line that passes 1, 2, and 11, 20. So we want to find the gradient first. That's the first step. y1 minus y2 over x1 minus x2, because this is the change in y, or the rise, and this is the change in x, which is the run, hence why rise over run. Okay, so it doesn't really matter which point you want first. I'm going to choose this one first because they're bigger numbers, and I'm going to do some subtraction just to make it easier for myself. So I'm going to go 20 and 11. So there's my y1, my x1. This is going to be my y2, x2. I'm going to minus 2 and 1. So 20 take away 2 is 18, divided by 10, 1.8. Okay, that's my gradient. And so using the y minus y1 equals mx minus x1, I'm going to use my gradient, 1.8. I don't know that x, don't know this y, and it doesn't matter which one I'm going to choose. I can either choose this one, 1 and 2, or I can choose 11 and 20. I'm going to choose this time 1 and 2 because they're easy numbers. Yeah. So my x is 1, and my y1 is 2. And now I'm just going to solve. That's 1.8x minus 1.8 plus 2y. So y equals 1.8x, going to add 2, which is plus 0.2. And there's your equation of the line. Yeah. You should get into the habit to check. And you should check with using your second point. Alright, so if I get my, so I'm going to use this 11 and 20. So 1.8 times my x value, which is 11, plus 0.2 gives me 20. And that's exactly what I want. So I know that I'm correct. I should move on to the next question. Okay. Alright, example 2. We want to find the equation of the line that passes through -4 and 5 and 3 and 2. So first step, gradient. Okay, which I'll use this one first. So 5 and -4, minus 2 and -3, because this is y1 x1, y2 x2. Okay, so 5 take away 2 is 3, -4 plus 3 is -1, gradient of -3. Yep. Okay, I'm going to plug it into my gradient point formula. Gradient of -3. And I'll just use this for the sake of it. So minus -4 minus 5. So negative 3x, that becomes a positive 4, so negative 12. I'm going to add the 5 over here. There's my y. Negative 3x minus 12 plus 5 means minus 7. Yeah. So, and just to make it nicer, I'll go take out the negative at the front, just to make it nicer. You don't have to do this. You can stay here and move on to the next question. As I said, we should check. So I'm going to use this one. So I've got negative 3 minus 7. Oh, there's 2. What did I do? Alright. Now, you may be given a story such as this, and all these linear relationships can be modeled with a straight line. So, the story says, the income from selling raffle tickets for Jones Club varies directly with the number of tickets sold. So, ideally, if we sell more tickets, we should make more money. Yeah? And so it's saying, if Joan has collected $75 from the sales of 30 tickets. So here, I'm going to keep my tickets as my independent variable. And the money I raise, or the money raised, is the dependent variable. So it says, this is just a graph, it says if I sell 30 tickets, I should raise $75. And the ideology is if I sell no tickets, I should have no money. Yeah. So we're having a straight line. What it wants me to find out is eventually how much would I be able to get if I sold 50 tickets, 100 tickets, whatever number. Okay. So first we've got to figure out how much per ticket. And if you think about it, the rise is $75. And the run, the number of tickets I sold, is 30. So I have a gradient of 2.5. Now, my y-intercept, if we continue this on, this being your x and this being your y, is 0 in this point. Because it doesn't say that she's got any money saved or she had to use money to buy the raffles. There's none of that. It just assumes that if we sell no tickets, we have no money. Yep. So no tickets sold means no money raised. So our y-intercept is 0. So the equation of this relationship, or direct variation, y equals mx plus c. The intercept is 0, so y equals mx. And here the m is 2.5. And the x is tickets. So 2.5 times the number of tickets. So if we want to find out how much we sold for 50 tickets, we go 2.5 times 50 is 125. If we want 100 tickets, 2.5 times 100, yep, 250. All right. If we have fx, and we said that was $750, so we get 750 equals 2.5 T for tickets. So the tickets sold to get $750 would be 300. Okay. So going back to our success criteria, hopefully with that examples, we would have been able to recognize that any linear relationship can be expressed as y equals mx plus c. Recognize that the line or any point of the relationship can be described as an x-coordinate and a y-coordinate. Understand the dependent and the independent. So usually the independent is your x because it doesn't depend, that's a consistent, and your dependent is what will change based on your x. And then calculate the line of the equation with the gradient intercept formula, the point gradient formula, having 2 points, finding the gradient, and then going to the point gradient formula. Okay, and that's the end of this lesson. Thank you.